Welcome to our webinar, Integration of IDS NXT Ocean in Factory Automation. Your host today with me here is Miriam Brenner from the B39 Academy. Miriam will be in the chat and will support you in either technical questions, and also if you have questions to the seminar, please write them into the chat. Miriam will collect them together, and then we try to answer these questions. My name is Patrick Schick. I'm Product Marketing Manager at IDS, and I will go together with you today through this webinar. Some housekeeping topics. First of all, if you have questions, as told, please write those questions in the chat. We will collect them and try to answer during the session or at the end of the session. If there is a question we are not able to answer during this session, we try to discuss this with the colleagues, and later on you will get a mailing. There you get also the slide set, the source code we saw today, or we will see today, and all the questions with an answer. So even if you're not feasible to answer this today, we will try to answer later on those questions. And now I would like to start with the webinar. I will switch off my video now so that you're able to concentrate fully onto the slides. Before we dig deeper into what is IDS NXT and how to integrate IDS NXT cameras into a factory automation system, for those who are not that familiar with IDS NXT Ocean, I would like to give, a short introduction into this topic. So in general, IDS NXT Ocean is a complete solution specially made for AI-based image processing. It enables you to solve tasks where classical or rule-based image processing has reached its limit. So you can solve your task with deep learning and neural networks without any programming effort and a deeper knowledge into the topics of artificial intelligence and deep learning. So why is this? Because we offer a complete set existing of cameras, our IDS NXT cameras, Rio and Rome, which are able to do an inference, so which are able to let a neural network run on the camera and give you results. There are also work similar like classical IDS UI cameras, so you can acquire images for the purpose of the training, for example. So we have an IDS NXT starter kit completely available, which you also could buy if you would like to start with NXT and like to explore. And in the starter kit, we have a camera included, the IDS NXT Rio, and you get a voucher for our IDS NXT Lighthouse training system. And here, all the knowledge of our AI experts here at IDS are included. So you as a customer, you do not have to bring special deep learning knowledge. We have the knowledge built into our training platform. The only thing you have to do, you have to bring your special knowledge about your topics. You have to label images. You have to take images. You have to label them, upload it to IDS NXT Lighthouse. Then the training, you can start a training and you get a neural net back, which you then can let run on the IDS NXT camera and do inference. So doing machine vision based on neural networks. This is a complete round trip. And today we will focus on the IDS NXT camera. In our last webinar, maybe you joined, we showed the information how to do this round trip, which components are necessary, and how easy it is to grab image, to label them, and let neural network run. Today, we want to focus on the topic how to integrate an IDS NXT into a factory automation, so that the results of the inference can be used to control a machine. So majorly, we don't focus on deep learning and all those topics. We want to work with the results of deep learning. And therefore, we will have a look to the three major topics. First of all, the possibilities to integrate IDS NXT in a factory. Then how we use the IDS NXT cockpit to set up an IDS NXT camera and to get results. And then we do similar with our IDS NXT REST API. But step by step. So first of all, how to integrate IDS NXT in a system and how to interact with an IDS NXT camera. One major part is the IDS NXT cockpit. Like our IDS UI cameras, if you're familiar with, you can set up the IDS NXT cameras completely with the cockpit. You can completely parameterize the system and then disconnect the PC in this case, and the camera works from now for itself and sends results to a machine, for example. We will show this directly later on live in the cockpit how this works. On the other side, we have the IDS NXT cameras. There we have support an REST API. We support the classical RS-232 interface and input and output. In our case, we will show how the two outputs, which are available for customer usage, can be configured, that IDS NXT can communicate with a machine. Yeah, so let's start. And I would like to show you how you can configure IDS NXT cameras. And as told before, we start with the IDS NXT cockpit. So besides the single connection to a factory, maybe over RS-232 or IOs, via Ethernet, you can connect the IDS NXT to a host PC where the IDS NXT cockpit runs on it, and then you can start configuring the system. I would not dig too deep into the cockpit itself. I would like to focus on how we set up NXT to communicate with the machine. So if you're more interested in general topics about the IDS NXT cockpit, we have a manual therefore available. I've provide the links here. So if you get the slide set later on, you can directly use the links, or you go to our website, and there you'll find under the manual sections everything about our IDS NXT cockpit. But now, for the first enough slides, I would say we switch directly live. I have shortly to stop. Here we are. So we're now in the IDS NXT cockpit, and if you normally start the cockpit, we're in the Finder area. Here you see our available NXT. We log in to the NXT. We are directly on a dashboard, and we can see that NXT is still working. It's doing inference here on a focus, and we're verifying if the focus is present, defect, or absent. Let us directly jump to the camera settings. So here you are able, as a lot of you may know from the IDS UI cameras, you can completely set up your camera. Here we can control exposure times, rotate, save images. We have an histogram available here. Oh, we see the red gain is not perfect, so you can also set those gains. We have an auto white balancing, so everything is available here in the cockpit. You can also switch trigger modes and control external flash. So that's the way how you can set up your camera. Then we offer different apps. We have a CNN manager, which does the inference for you. Crawler we showed last time. It's how to acquire images for the training. Today we will focus on the GPIO gateway and the RS-232 gateway. And first of all, we want to set up our system that we do a good inference, that our networks runs well. So we set the right ROI. We look a bit about the exposure time to make it perfect. So here we have an OK foam kiss. Then we put another one here, and we will destroy this foam kiss. And you see now, okay, now we have a defect one. We could reduce a little bit the exposure. And I have to eat in foam kiss. So as you see, inference is working well. So we can ensure via the cockpit, okay, our camera works well in the application. You do not have to program anything for it. And but now we have to communicate the results to our machine. And therefore, we can use, for example, the IOs or the outputs of IDS NXT. With our first version of the IDS NXT, we focused that we are able to talk to nearly every machine. So we don't focus on specific industrial protocols because there are a lot of them outside, and it's always the question, okay, which would be the right one? We focus that we really can support the simplest available communication, and this is either the I/O via electrical signals or an RS-232 communication. Both are normally available at every PLC, at every machine control. And we have the REST interface, and for sure we will enhance in the future. You will see later. But for now, we communicate over the outputs and over the RS-232 gateway. And that's quite easy. Sorry. We define here, which is our class when we have to react. In this case, we want to go for a present. And if the threshold of the inference is higher than 90%, we expect, yes, this is a good hit. And we then send a signal to the output 1. You can set here the activation time, means how long shall be the signal sent. I just increased this here a little bit, but this is only for the purpose that you can see it later on. On the other hand, we can set a second class. We can set, for example, a defect class. So as soon as IDS NXT sees a defect foam kiss, we output this to our output 2. So this one gets too high. And now let's see how it's worked, because that's everything. We have set it up. We say, if there is a foam kiss present and the threshold, we can say to safety of 90%, please set output 1 to high. If we have a defect one and the threshold is higher than 90%, please send a signal to output 2. So with this setup, I can easily control a machine. Is this okay? Is not okay? Is something available? Is something not in place? And I can show you now. We have on the CNN manager, we have an present with probability of 100% in this case. The GPIO gateway is set, so we go to the interfaces, and you see here output 1 flickers. So we see there is a present foam kiss, and we send signals to the machine. Okay, every foam kiss we see is okay. And now I will exchange the foam kiss. We don't have configured absent. We have configured a defect foam kiss, which I put now under the camera. And you can see output 2 sends now signals to the machine. So let's verify. Yep, it's a defect one. And now with this easy setup via the cockpit, we have built up a complete machine control over the IOs, and now you have the ability to disconnect the IDS NXT camera from the host PC, and the camera will still work on. So compared to classical industrial cameras like the IDS UI cameras, where all the time a host PC has to be connected, that it works fine because the machine vision runs on the PC. With IDS NXT, we have in a short time completely set up the system. We set up the machine vision via our neural networks, and we define the communication via the IOs in this case to the machine. And now the system just runs as you expect from an edge device, completely without any host. So this is a setup over the IOs. One thing I forgot to show you, in the GPIO gateway here, you could set an app and a source as a result source. So we want to see from the CNN manager the inference, and we want to see from the CNN manager the probability, and we want to react on this. So pretty easy setting up the outputs. Switching to the RS-232 gateway, it's nearly the same easy. So you set your source. We want to communicate the inference and the probability over the RS-232 protocol. In the gateway itself, we set a header and a footer. So what shall be at the beginning of the message, and how shall the message be end? And that's it. In the interfaces, you can set all necessary baud rate and everything. And now the RS-232 communication works also without connecting the camera to a host PC. In this case, with RS-232, we are also able to communicate more than okay, not okay, or present or defect. In the RS-232 stream, we have the complete results of the inference. So in our case, we propagate 3 results. If it's defect, it's present or absent, and the probability and the inference time for it. So there is the complete information is included in the RS-232 stream. So again, IDS NXT cockpit, an easy way to set up your IDS NXT camera graphically without any programming effort. In round about 5 to 10 minutes, we have set up a complete system. So this is one possibility for you to interact with IDS NXT and set it up. And now I change back. Are there questions so far? If not, I would go ahead. I expect that there will be questions, but we can answer them later on. So now we want to have a closer look to our second or a REST API. we want to go, and I would like to show you how we could interact, program, and parameterize the IDS NXT camera. So for one part, at the moment, with the in-out and serial data, we communicate with the machine, and rest we communicate to an host PC. I think a lot of you may think, okay, why does IDS decided for the using REST? I mean, they're building normally industrial cameras, and there we talk about interfaces like GennyCam or the IDS proprietary protocol, why they are using REST as one of their major interfaces. One part of it is we look on IDS NXT camera as an IIoT device, as a device for the industrial Internet of Things. And in this cloud, in this area, interfaces like GennyCam or the IDS proprietary camera interface are way too heavy. They bring too much overhead with them because they are normally PC or host based, so you need to install a component on your PC to communicate with. And here with IDS NXT and the REST interface, we support a much more lightweight communication, let's say. So one of the major benefits is that nearly every host system can work with IDS NXT when, as far as you are in the same network and you have a web browser available. So you can send over a browser easily commands to IDS NXT or via a console. I will show this to you now in the live demo. So we have a much more easier communication. There has to be no specific adaptations from IDS that you can use a host system to communicate with IDS NXT. Together with this webinar, we also offering a tech tip where we go more into the details, also into the details about the source code I will show now to you. So feel free to download this tech tip and have also a look to this tech tip. But for now, I want to again go practical, and we want to go live, and I would like to show you how to work with IDS NXT via the REST interface. Oh, I see there are some questions are raised. So I will just get them. Sieht man jetzt mein Bildschirm? Genau, ja. Okay, it is possible to configure a custom model in the camera. I'm not sure what you're understanding with custom model. If you ask about a question, if you can upload your own neural networks or your own app. So developing your own app will be feasible with the next release. I'll tell about more this later. At the moment, we only support classifications with the net with IDS NXT, but also there is more to come. How many images did you use for the training? A classical question. We have. I make this easy because we don't focus on deep learning in this topic. In general, we say it depends on your issue. As more images as are available, as better. But before you start to solve a complete application with it, you should go the way that you acquire, let's say, 50 to 100 images per class. Maybe decide, reduce your problem down to 2 classes, and then start training, which is pretty easy with the IDS NXT Lighthouse. and see if your problem is solvable with deep learning and neural networks. So this would be the first start. On the other hand, I would like to invite you to a webinar which we have next week. Here, there is our artificial intelligence specialist, Dr. Alexander Windberger, will hold a webinar round about those topics. So how is IDS NXT Lighthouse working? What are the requirements, let's say, for IDS NXT Lighthouse? And also one of the topics I would expect is, okay, what are the typical purpose, how many images you need, and so on. So if you have more questions regards this, join this webinar next week. And there is the question, can we publish the bounding box and IDs of objects from the cameras to the host computer? Via REST, this is feasible. We want to dig this time not too deep into this topic, but with REST, we have the possibility to request the ROI coordinates and know then in which part of the images we do inference. It gets more interesting when we look at the upcoming Ocean release, which I'll will tell you later about it when we have object detection or multi-classification. But yes, with REST, this is feasible. Is it possible to upload our own images in Lighthouse to train a neural network? Yes, it is. I mean, we say it's better that you acquire the images in the situation and with the camera you use also later on for the inference. But you can also use your own images. I showed this in the last webinar, or told this. We make examples here where we did a network which inferences against cookies, so Christmas cookie inferencing, and there we grabbed images from our own baked cookies via smartphones. We grabbed some from the internet, and we trained the network with a complete various images from various sources, and still we get pretty good results during the inference. There is also a video available, a short Christmas teaser on our YouTube channel, I think, where you can see how this is working. So, but let's come back to the topic for today, how to integrate and interact with the IDS NXT camera to get results and to set up the camera. In this case, now we're looking at the REST interface, and I want to show you how easy it is to interact and configure via REST. So first of all, I will show you a tool. There are a lot of REST, so-called REST clients available outside. I'm using Postman. This is the client which I like. Maybe you know others, then please use your own client. And here you can see I only have to know the IP address. I have to know the node which I have to ask or which I have to talk to. This description you find also on our website in the documentation, which REST nodes are available. And here I want to go and say, okay, what are the current parameters of the camera? And okay, I send this command, get IP address camera, and then I get back the results. So we have currently set an exposure time of 70,000 milliseconds, a frame rate of 32, no gain, and auto gain is off. I will shortly switch to the IDS NXT cockpit and we can verify. Right, here we are. This is our settings. We can reduce the lighting a little bit here. Fire the command again. And we have updated exposure time here. So a pretty easy way to communicate. We only send the request and we get a feedback back, and then we can directly reuse this. but you would like to program. And here we have only a tool which we can set up commands. The nice thing, such kind of tools, is that they often, in case as Postman, offer a code generator, which I open up now. You see here, I have the command, I open the code, and I get code generators for different languages, starting at C, C#, Java, up to plain PowerShell commands, which are today available on nearly every Windows machine. I can use wget, which are also available on the most systems. And I will show you now, okay, we have here a code for the PowerShell. I copy this code. I go to my PowerShell. I paste the code here. And plain in the PowerShell, without installing anything, using only the system, the available parts which Windows brings with, I can send a request to an IDS NXT camera and get a feedback here, as similar as I had in Postman. So the exposure time, frame rate, and so on. Similar, it works with Python. So I can switch here. It's still the same command. I switch here to Python. I only know that I have only an HTTP client, no HTTP secure client. So I change this. I copy the code, and now I have a Python code in a Python programming language. I paste the code, send the command, and also here I get the exposure time, the same result as out of Postman. So this is one of the major benefits when we look at REST, that you really have we don't need a specific installation. We can use plain base plain, I forget, Bordmittel. We can use what our system brings with us. Sorry, I was searching for the right word. We can use the things as Windows, a Linux, or a Mac system, or your Android brings with it, and can start interacting with NXT. We can access it programmatically. I showed you now how to get values, and now we want to dig a bit deeper, and also how to set values in IDS NXT. Therefore, I'll jump into so-called Jupyter notebooks. For those of you who are not familiar with it, Jupyter notebooks is a combination of documentation and live running code. So here we can document topics, and we have code included here. And this code is not only here as on a text base. We can really directly let this code run. Also, this notebooks and those code is included in the tech tip I told before to you. So even today, not now because now you're in the webinar, but today you can download this code and can use it as a start to program your own code for IDS NXT, in this case based on Python. We decided to use Python because from our experience, Python has at least two good points. It's running on nearly every system, and Python is a programming language with is easy to learn, and it's easy to transfer also into other languages like C# or Java or C++ if you use this. So this makes life then pretty easy when you start, in this case, with Python. And on the other hand, there's Jupyter Notebooks supports Python pretty good. So we decided for this. And now I will do the same. as we have done in Postman. But now much more programmatically. So we import our HTTP connection. Then we set the IP address and the credentials to access IDS NXT. We need some more libraries to show an image. And then we have a pretty easy get command. So the major command we have to send to get an image is only this request command with we send an option, okay, get the camera image. Camera image is a node, which you also find in the documentation. So we send this command now out. And there is the image of our current object under inspection, a defect foam kiss. If I change here, I change to a present, to a good one, that you see that nothing is faked here, that this is live. So some lines of code to easily access and acquire an image. This is your major command, and this command works on every system where Python is in this case available and the HTTP client. So we get an image. Also, we can change values from here. We connect again to the NXT, and then we have a look on the current camera parameter. So this is now the similar command as I showed you in Postman. So we send a request, a get request to the node of camera, and then we get exposure time, frame rate, and so on. And now we want to change the exposure time. So in this case, again, we only send the request. You see, it's all the time the same command. But now we have to say, okay, we want to patch a value on the camera node, and we want to patch the value exposure time. As you've seen above, the keyword is exposure time. So we send this command. We get the feedback that this command is accepted and is set up. Let's verify the new settings. Okay, we get the result here. We set the exposure time to 94,979. This is IDS NXT doing automatically for you because we set the next feasible value. If you set 50,000, which is not feasible for IDS NXT, we set the next possible value, similar as we do it sorry, on our UI cameras. And before I show you download now the image or acquire an image, I switch to the IDS NXT cockpit, and here you can see the value is changed. We have a totally overexposed image. And if I send this command now here, we get the same totally overexposed image. So I want to go back to our former value. I think it was around about 70,000 milliseconds. We send the command again. We see the new value is set. Let's acquire an image. Here we are. We have set back the value to our to get a good exposed image. So with the patch command, you pretty easy can set values on IDS NXT. And with this knowledge, we want to go a step further. Again, we connect. And from our manual, we know that camera has also node trigger. And we request from this trigger now, okay, again with the get command, what are your current values? And we see there different debounce, delay, which edge, and so on. Our value or parameter we focus now is the trigger type. So it is currently set to free run. IDS NXT supports 3 different types of trigger modes, so free run, hardware, and software. And we want to change now the code, the trigger type to software, because this is the type we can control also via the REST interface. So we send, again, we patch this value on the node camera trigger. We patch the value trigger type to software. I switch to the cockpit, and here we are. Trigger type is changed to software. Nothing changed as now. I can hold my hand under the NXT. You won't see anything. But if I acquire image, here is a pretty overexposed fingers. And I can also acquire this image here. This is still an old image because we don't force a new trigger. This, again, we can do with the post command. So we send a post command to the node camera trigger. Again, this is similar, the same. We request an NXT and we only exchange those 2 values, send a post command to camera trigger. An image gets acquired, and for sure then we have to download the image to our system. And here we are. Again, my fingers are gone from the image. We have again an image of the foam kiss. So a pretty easy way to control the IDS NXT camera via the REST interface. And last but not least, for today, I want to show you that also the setup of the I/O gateway is feasible via the REST interface. As I told before, you can completely configure IDS NXT either via the graphical user interface or via the REST API. We support every command also via the API. So again, we connect to it. We verify which apps currently installed and running. So we have here the GPIO gateway, and we check what is feasible on GPIO gateway. We get the options of the GPIO gateway, and here we have the node configurables. Maybe if you remind, I'm just switching to the IDS NXT cockpit, go to the GPIO gateway, and also here we have the headline configurables. So these are the node we have to modify now. So let's see the current values. And we see that currently when the keyword 1 is present via a threshold of 90%, and the keyword 2 is defect by a threshold of 90%, we communicate over the output 1, or this output gets communicated over the output 1, and keyword 2 gets communicated over the output 2. We similarly can then set the duration, and we can request the last result. And now we want to set that also not if present, if absent. So if no foam kiss is there, we want to communicate this to output 1. So again, it's only this single line. So we send a request. We say, okay, please patch the configurable of the GPIO gateway. Use now the keyword absent. And if this keyword absent if is there with a threshold of 90%, communicate it via the output 1. So we set it. I switch to the IDS NXT cockpit, and you see here, okay, it's set. Absent is set over the output 1. Let's see if it is working. I have to switch back to free run here. And we still have present because this seems to look similar. But the probability of absent raises, this is also typical behavior. So we could exchange. So we could also say, okay, if the possibility of absent races is higher than 0, we could also lower here the threshold. And then again, our output on 1, we are on the threshold with absent. Oh, a little bit lower it more. We start communicating via our interfaces here. Okay, this is another possibility now to set over the REST interface to control the complete IDS NXT camera. Yeah, we do the same via cockpit or via the REST interface. And I also saw my error now why the absent was not working, because now it's working. I've put this a sticker on the board that to know where my foam kisses has to be, but this was not trained before, so this was nothing the network saw before, so it could not learn. And now you see I get rid of this sticker, and now we have the trained background, and also now our system can still see, okay, it's present, it's defect, and it's absent. Makes my life harder because I have to search the camera now. But the GPIO gateway is again working well and sending the commands if there is something absent. So I switch back to the presentation. So we saw now how we can interact and program IDS NXT via the REST interface. And what we also see more and more is that REST comes to the factory floor, that sensors are communicating via REST, and even that we have first PLCs on market, which also REST includes as a standard protocol, let's say. So we got through the webinar now. I showed you the possibilities how you can integrate IDS NXT in your factory via the IOs and RS-232 or via the REST interface. How to parameterize IDS NXT via the cockpit using a graphical user interface. And last but not least, I showed you the lightweight IDS NXT REST API, which makes it pretty easy to configure from nearly every host over a lightweight interface your IDS NXT camera. And now it's up on you. I saw that Miriam is writing a lot of questions. So let's see. About the questions. Okay, there are more going into the deep learning topic, but that's not an issue. How many classes can be configured with NXT camera? This doesn't depend on the NXT camera. You configure the amount of classes you need to solve your issue. So if you have only an NIO decision, you need 2 classes. If you would verify if you have a defect, or you have you want to know if you have banana, apples, oranges, and so on. So you have defined for every result you want to have, you have to define a class. And if there is a maximum amount of classes, I think this is more limited by IDS NXT Lighthouse, and therefore this is again a question for the webinar next week, or to our expert, Dr. Alexander Windberger. How many classes can be configured inside of Lighthouse? So this is more a question for this webinar, but nevertheless, or maybe you joined this webinar then. Does the image bit depth change when upload images in Lighthouse? I do not know, to be honest. We have to ask for this, but we will send the answer with the mailing. Can you still use the C++ IDS SDK API like with other cameras? No. This is a question is quite easy to answer. At the moment, we support the REST interface here and not the integration in our IDS SDK. But maybe this is a feature request from you, then do not hesitate. We note this down now here. Maybe you could come into contact with your responsible in your country and discuss the topic, why you would like to integrate this in the IDS SDK, and we can dig a little bit deeper into this topic. What if I have a pre-trained CNN model from TensorFlow or any other AI framework? It is possible to upload or needs a conversion. Yes, this is possible. So in generally, we support this easy-to-use workflow with IDS NXT Lighthouse, where you especially do not have to know anything about TensorFlow or Keras or any other AI framework. You put your images, your labeled images into Lighthouse, and then you can start training. You get a network which is able to run on IDS NXT, and you're fine. But if you have still trained networks, which are, for the moment, are trained with Keras, we offer a special tool, this so-called IDS NXT Ferry, which does what you're asking. It converts and uploads your own networks, as long as they do classification, to our IDS NXT cameras. So if you want to dig deeper into this topic, again, please come in contact with your responsible IDS contact and ask there for the IDS NXT Ferry tool. Maybe I want to also give you a short outlook. This solves the one or other question or raises some. With the release of IDS NXT Ocean 1.1 end of this year, we also plan, I have to say plan, to bring the following new features. So supporting OPC UA as a first industrial protocol with the IDS NXT cameras. We will enable customer vision app development so that you can write your own apps for IDS NXT cameras. At the moment, only IDS cameras can run on IDS NXT. With the release of Ocean 1.1, it's planned that also customer vision apps can run. And we will allow multi-AOI classification so that not only one region of interest or area of interest can be used in an image, also that more than one area of interest can be set inside an image, and you can classify then this multiple or the content inside of this multiple AOIs. On IDS NXT Lighthouse side, our training platform, we plan to offer export and import of formal trained nets. We offer versioning so that you have a better control over your networks. When did you created this, and so on. And additionally, we will provide object detection as a complete new model. So as app on the camera and supporting labeling and training on IDS NXT Lighthouse, in this case, an object detection. And we'll bring 2 new languages, in this case, French and Japanese. That's so far from my side. Thanks for joining the session. I hope it was interesting for you. As told, you get the slide set later on. And I wish you a nice day. Goodbye.